Good afternoon, dear student. So, today also here we are to start the new topic in the chemistry. So, before that last day or last class we have learned something that is very new to us also in class 9 about the electronic configuration on the basis of subcell. So, what we have learned yesterday. So, I start from there. So, please see the slide. So, let us revise from there. Okay. So, yesterday we have started with the electronic configuration on the basis of cell. So, from there I will start. So, electronic configuration of some element is shown in this table there. So, hydrogen atomic number 1 having only one electron, its electron is placed in K cell. Okay. Similarly, helium having 2 electron in its outermost 2 electron is placed in K cell. Similarly, lithium in K cell 2 electron and in L cell 1 electron. In that way, beryllium 2 that is in K cell 2 electron and in L cell 2 electron. In that way, we have studied that the electronic configuration of various various element in cell, like fluorine 9 atomic number is 9. So, it is placed as 2 7 and after that neon, look at there, neon has atomic number 10 and its electronic configuration is given as 2 8, is not it. So, there having 8 electron in the outermost cell, that is in L, the capacity of L is 8. And now, what happened when we enter 8 electron in the last cell, that is L, in case of neon it is complete, okay, having 8 is stable. Now, what will happen, the next element, that is sodium, having atomic number 11, that is 2 8 1. So, in L cell in previous it is completed. Now, that one extra electron has entered in M cell. Okay. So, similarly, magnesium having atomic number 12, its electronic configuration will be 2 8 2, that is one extra is added to the M cell. So, like that way aluminum has electronic configuration of 2 8 3, silicon 2 8 4, phosphorus 2 8 5, sulfur 2 8 6, chlorine 2 8 7, and after that again argon, in case of argon 18 2 8 8. There in M cell we can adjust according to the 2n square rule 2 3 square, that is 3 3 is 9, 2 is 18. Yes, 18 electron we can adjust in a last cell of argon, but after 8 electron is filled in argon, it is completed. Now, we can say in M cell it is complete. Now, next electron in case of potassium having atomic number 19, 1 electron we can enter there in M by making it 9, but it is not so, because it is the last cell in which we are entering. So, that one electron goes to the N cell. So, like that calcium electronic configuration is 2 8 8 1, okay, 2 8 8 1. So, in this way the electronic configuration on the basis of cell according to the Bohr scheme is shown here, and you have already studied about it in previous classes. So, just I am revising it. Okay. Next slide. So, here the atomic structure of various element and how the electron are arranged. Okay. It is shown in this diagram. Here dotted point is showing us the number of electron placed in an atom. Okay. So, for case of hydrogen, in the nucleus there is one proton no 0 neutron, and 1 dot is written on the cell, drawn in the on the cell, that indicates 1 electron is there. Similarly, in helium, having atomic number 2, 2 electron are placed and it is filled. The first cell, that is K cell, is completely filled. Now, next electron is enter in case of lithium in another cell, isn't it? So, look there. So, similarly, like beryllium having 4, so 2 electron in the first cell and the 2 electron in the second cell. So, boron 3 electron in the outermost cell, 2 electron in the inner cell. So, like that, carbon 4 electron in the outermost cell, 2 electron inner. So, in that way, nitrogen, oxygen, fluorine and neon. So, in case of neon, 8 electron is there completely filled, that is, that state having 8 electron is fulfilled there. So, second cell capacity is 8, it is filled. Now, we will study later on what is the specialty in neon. So, next in element after neon, it is sodium. Okay. Next slide. In sodium, what happened? Atomic number is 11, its electronic configuration is 281. So, in atomic structure, it is shown like that way. So, there are how many cells? 3 cells are there, in which all 11 electrons are adjusted, in which outermost cell contains 1 electron. Yes. So, magnesium, how many electrons are there in outermost cell? 2. In aluminum, 3. In silicon, 4. In phosphorus, 5. Sulfur, 6. Chlorine, 7. So, look at there in chlorine, it is very important during chemical reaction. In most of the time, chlorine, sodium structure and like compound like sodium chloride, we will study in coming days. So, this atomic structure you should know. So, how many cells are there, and in each cell how many electron we can place, or it is there. So, we have to know. So, like that, argon having 8 electron in outermost cell, 8 dot structure is shown, that means 8 electrons are there in the outermost cell of argon, that is third cell KLM in M cell. So, after M, though it may accommodate more electron, since it is the last orbit, we cannot place here more. So, next we have studied about the potassium, and in potassium 1 electron in the outermost cell, and after that we calcium, in calcium 2 electron is there. So, here I am revising it more time, I am giving more time this topic and I am going very slow. Why it is so? Because it is very much important for your further studies, for higher studies, isn't it? So, if you will be able to understand the atomic structure, electronic configuration, then later on it will be easier for you. So, this much we have studied in atomic structure. Now, next slide. So, yesterday again we have studied about the cell and subcell. I have told that cell is further divided into subcell, and they were 4 and they were denoted by letter S, P, D and F, and whose meaning was S for sharp, P for principal, D for diffuse and F for fundamental. And already I have told how many maximum electron we can place there in a particular subcell, that is S2 maximum number, in P we can place 6, and in D maximum 10 electron can be placed, and F 14 electron can be placed. That already we have learned yesterday. Now, next again I have told in cell how many subcell are there. In K cell there are only 1 subcell, in L there are 2 subcell, that is S and P, and M there are 3 subcell, that is S, P and D, and N there are 4 subcell, that is S, P, D and F. So, this sequence and the number of electron that can be adjusted in a subcell you should remember. Okay, it is very much important to know the chemical and physical property later on. Okay. Now, next slide. So, yesterday again we have studied how to arrange electron in various subcell. So, above principle gives us how will we adjust electron in various subcell. Okay. So, what it in a German language, Aufbau means build up. Okay, build up, that means in German language it is build up. So here we are building how the electron will build up in the electronic configuration on the basis of subcell. So here n equal to 1 in that diagram, if you see the chart sequence, it is given as I have already mentioned you, I have taught you yesterday. So I hope you have understood. So 1 s, the capacity is 2 s, then 2s it will go, after filling that it will go in 2p, and after that 3s and 3p, 4s, 4p, in that manner it will go. So according to this principle, the electron are filled up in the subcell in the order of their increasing order of energy level. So according to the energy level, lower energy level should be filled first, and after that only another higher energy level should be fulfilled. So lower energy level are filled first, there it is written there, you can see clearly. So the order can be shown in figure. So that side, other side we have discussed, and it is written as while writing the electronic configuration. So 1 s2, there I have already told you, 1 indicate the cell, 1 whatever, here 1 it is there, it may be other also. So cell, row, and their possibility 1 to 7, like that we have discussed yesterday also. So now next slide. So some example. So yesterday already we have I have told you I have shown you the electronic configuration on the basis of subcell of various element. For time being I am showing only few element, like hydrogen having atomic number, its electronic configuration is written as 1s1, that in s subcell 1 electron is entered. In helium 1s2, that means 2 electron, the capacity of s is already completed. Now extra electron, it will go to another subcell, that is 2s. So in lithium 1s2, 2s1. So like that in beryllium 1s2, 2s2. So oxygen and calcium also I have shown you there in the picture, in the slide. So you can see, and I have already discussed it about that. And there are some exceptions which I have already told you, that in some cases, in mainly in D subcell, having 5, that is half of the total capacity, is more stable condition as compared to other, and having 10 also full, that is also stable. So in case of chromium, if you go according to this principle, you will have 1s2, 2s1, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d4. This is the expected configuration that we come across by knowing it all. Yes, but in actual what happen, having 4 electron in the D subcell is the unstable stage. So to avoid that, the energy from the electron from the previous cell, that is S, is given to D subcell to make it stable, D5, and S1 is there, that is in S subcell. So similarly another case is in copper. So copper having atomic number 29 also shows some exception there. So because if you do in normal condition, the electron configuration comes as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d9. But 9 is nearest to the 10, that is complete capacity of the D subcell. So what happen, as from the S, 1 electron is transferred and it becomes D10, it becomes more stable, and in this way we write the electronic configuration of various subcells. So these are the things which already we have studied. I have revised it because it is very much important, so that you will understand. This is the new topic. You will find some difficulties to understand this topic. Okay. So now let us move to the next slide. So today actually from this point we have to move study today. So first we will study about the valence shell. And valence shell is what? The outermost shell of an atom. Okay, the outermost shell or orbit of an atom is called valence shell. So where we are placing the electron, that will be last cell is called valence shell. If you see the table out there, I have shown you the electronic configuration of some element, special element, like helium, boron, magnesium, potassium. So, some examples are there to understand what is valence shell. Okay. So, if you see the electronic configuration of helium having atomic number 2, its electron are placed in k shell here 2. Okay. So, here which one in which shell the electron is placed? K shell. It has only one shell. So, all the electron are placed in K shell itself. So, K is the last shell. So, it is called valence shell. So, and how many electron are there in the K shell of helium? 2. So, its valence electron is 2. And in case of boron having atomic number 5 and electron are placed like in K shell 2 electron and L shell there are 3 electron. Okay. So, 3 belongs to L shell. That means, the last shell for electron to be adjusted is L. So, that is why L become the valence shell, and the number of electron in the L shell, the last shell is 3. So, valence electron is 3. Okay. So, in magnesium atomic number 12, its electronic configuration is in K shell 2 electron, in L shell 8 electron, and in M shell there are 2 electron. So, in this case there are altogether 3 cell or 3 rows in which electron are arranged, and in which outermost row is M. Okay. Outermost cell is M, and in that M 2 electron is there. So, valence shell is M and valence electron is 2. Is it clear? Last electron is entering in M shell, that is why its valence electron valence shell is M, whereas valence electron is 2. Similarly, in case of potassium atomic number 19, 2881, in K 2 electron, in L 8 electron, in M 8 electron, and in N, in last electron is entering in N shell. So, N shell is the valence shell, whereas 1 is the valence electron. So, is it clear what is valence shell and what is valence electron? Okay. So, now next slide, let us see. Now, we will understand the octet and duplet. Okay. So, here we have already known what is the electronic configuration, how it is done on the basis of shell and subshell. Okay. So, if you see the table there, I have written the electronic configuration of those elements whose last orbit are completely filled according to the rules. Okay. Having 8 electron, and in case of helium there is 2 electron in K shell itself, and K shell having 2 is stable. Okay. Having 2 electron in the K shell is stable condition. So, in helium having atomic number 2, having a 2 electron in the outermost shell is stable condition. Okay. So, this case helium is called noble gases or inert gases, as it has stable electronic configuration, which is called duplet. What it is called? It is called duplet. So, the definition written there, the group of 2 electron in the outermost shell, that is mainly K shell, is called duplet, as in helium. Okay. In helium 2 electron is there, so it is stable. So, it has duplet. Okay. And other element like hydrogen having 1 electron in the K shell. Similarly, lithium having 1 electron in L shell, K L 2 1 in 1 there in L shell. So, this element what they will do, they will try either to gain or to lose, to have 2 electron in the K cell, okay, to become stable. So, there the transferring, gaining or losing, that will be called as the valency. So, all the other element nearest to the K cell, they will try to attain or maintain 2 electron in their valence cell by either by transferring or by sharing electron, and that rule is called duplet rule. So, duplet rule definition, it is written there. The element like hydrogen, lithium, beryllium try to maintain 2 electron in their valence cell by transferring or sharing electron is called duplet rule. So, the element which is shown here, all they are called noble gases. Why they are called noble gases? Because their outermost shell is complete, okay, they are stable. So, about the duplet it is clear, having 2 electron and stable. Now, other element except helium, neon, argon, krypton, xenon and radon having atomic number 10, 18, 36, 54 and 68 respectively, their electronic configuration like 28, 288, 28, 18, 8, 28, 18, 18, 8 and 28, 18, 32 and 8. So, in this case, if you see all red color, that is in last orbit all electron is filled according to the rule. So, they are stable, and because they are stable, they do not go under chemical reaction. That is why helium, neon, argon, krypton, xenon and radon, they are known as the inert gas or the noble gas, because they do not undergo any chemical reaction. So, look at there at the down, what is octet rule and what is octet. So, the group of 8 electron in the outermost shell is called octet, as in neon, argon, krypton, xenon and radon. And what is octet rule? The element which try to maintain 8 electron in their valence shell to become stable either by transferring or by sharing the electron is called the octet rule. Is it clear? What is duplet? What is duplet rule? And what is inert gas? And why helium is called inert gas? Why neon is called inert gas? Why, what you will say? Why neon is called inert gas? Because its atomic number is 10 and its electronic configuration is 2,8 and it has stable electronic configuration and does not take part in a chemical reaction. That is why neon is called inert gas. Okay, like that the element may be changed, question may be given like this: why argon is called, why krypton is called, why xenon is called, why radon is called inert gas. Okay. Now, next slide. So, just now I have discussed that the element, those which are having stable electronic configuration like noble gas, they are stable, but other element like except helium having duplet, other element they will obey, they will try to attain 8 electron in their valence shell. Okay, their valence shell, they will try to gain 8 electron to become stable, and few element they will try to get duplet. So, what will happen? How they will attain? Now, question comes, how they will attain that electronic configuration. Okay. So, those element other than that, they are unstable. So, the main reason is that they are not stable, they do not have stable electronic configuration that of the inert gas, and they will always try to gain the electronic configuration of that of inert gas. So, how they can do? Okay. So, that is written there, a valence electron, if the element while doing electronic configuration, if they are having either 1, 2 or 3 electron in their outermost shell. Okay. If they are having 1, 2 or 3 in their outermost shell, they will lose electron from their outermost shell they will try to lose this electron to other element to undergo chemical reaction and form a bond. Okay. So, that may be different bond. They are electrovalent bond, that is called ionic bond, and covalent bond, that also we will discuss there. So, in next class we will study about that. So, the element whose while doing electronic configuration, if they will have either 1, 2 or 3 in their outermost cell, so they will lose electron and become stable, and they will become stable, and if they will lose, then they are, or their characteristic will be called as metals. So, those elements having 1, 2 and 3 in their valence shell will be known as the metals. Okay. And the element whose valence electron, okay, is 4, okay, generally they have a less tendency to lose electron or to gain electron. Instead, they will try to share their 4 electron with other element. Okay. So, they will try to share. So, this element whose valence electron is 4, they try to share the electron, their electron with other element, they will be termed or grouped as the metalloids. Okay. They will be grouped as a metalloids. And similarly, those elements which are having electron or valence electron as 5, 6 and 7, that means in outermost cell, if they are having 5, 6 and 7 in their outermost cell, now they cannot lose electron, because to have stable electronic configuration they need 8. They need 8, and if they will lose 5 electron to other, they become it is less possibility that they will lose 5 electron. Instead, what they will try to do, they will try to gain 3 extra electron from other element to become stable. Similarly, element which are having 6 electron, they will try to gain 2 electron. Similarly, the element which has 7 valence electron, they will try to gain 1 more electron, so that they become stable and they will attain the nearest stable electronic configuration of inert gases. So, how they will try to attain stable electronic configuration? By gaining the electron, and those element which will gain electron from other to become the stable, they will be termed as non-metals. So, they will be non-metal. Is it clear? Okay. Now, look at the definition of valency. So, from here, the element, those elements which are not stable, try to get stable electronic configuration by gaining or by losing. Okay. They will have a capacity to combine, their intensity to be stable. Okay. So, how they will lose, we have studied. So, from this what we can sum up, valency can be defined as the combining capacity of an atom, of an element, or a radical. Okay, or a radical. So, this term radical we will discuss in coming classes. With other to form a molecule or a compound is called valency. So, you can write what is valency? The combining capacity of an atom, of an element or a radical with other to form a molecule or a compound is called valency. For example, if you look at the figure there, sodium atomic number is 11, its electronic configuration is 2, 8, 1. So, in outermost cell how many electron is there? 1. So, if it lose 1 electron, okay, if it lose 1 electron from the outermost cell, then how much electron will be there? 2, 8, and that is what? Stable electronic configuration. Okay. So, valency of sodium become 1, because after losing 1 electron it will attain the inert gas electronic configuration of 2 8. Okay, so its valency is 1. So sometime question can be asked, what is the valency of sodium and why? The valency of, answer will be, the valency of sodium is 1 because it has 1 electron in its outermost shell and it can lose 1 electron to get stable electronic configuration. Its valency is 1. Similarly, magnesium 2. Okay, it can lose 2 electron to become stable. So there it has written valency is 3, mistake. So there should be 2. In silicon 4 outermost shell, so it will share the electron. So I have shown it with different color, it will share their electron. Now in phosphorus 2 8 5, having 5 electron in the outermost shell, it requires 3 more electron to get 8 electron in the outermost shell and become stable. That's why its valency is 3 there. In chlorine 2 8 7, it needs only 1 electron to be stable, so its valency is 1. So you have chlorine, very much important element during the chemical reaction. Next chapter we will study. So here 1 electron, if it will gain, it will have stable electron configuration and it will be stable. So like that, argon atomic number 18 2 8 8. So having 8 electron in the outermost shell is already, I have told, octet stage is achieved, and being 8 electron, neither it can lose nor it can gain. It will not give. If it will give also, it will be unstable. It will gain also, it will be unstable. So it will not take part in a chemical reaction. So its valency is 0. So it is inert gas. Okay. So these things about the valency, how it is found out, why it is so, we call it different element have different valency. There are some variable valency, there are some element which shows variable valency. So we will discuss in next class. So now please look at the board. So today we have discussed many things from the previous days also. So hopeful you have understood. I am going slow as it is very important topic. Okay, try to understand, it is new topic to you also. So please try and study at home, and if you have any problem, ask to your concerned teacher. For today this much. Thank you.